Hello everyone, I'm Maheep Singh, and this is my uh, presentation for task 3. This is my second presentation for task 3 for the pre-requirements of GSOC 2025, and my presentation is titled Utilizing Dart Dev Tools to the Fullest. For this presentation, I'll be moving along Google slide deck while also demonstrating the dev tools through a demo application that I've created. Now, first of all, what are dev tools? Dev tools refers to a suite of performance and debugging tools for Dart and Flutter. And Flutter dev tools and Dart dev tools, both the terms refer to the same set of these tools, which can be accessed either using a browser or they can be viewed directly in the IDE. Now, first of all, I'll show you how you can access these dev tools through VS Code. For that, all you need to do is open up a Dart application, which I have open here, and press Ctrl Shift P. Now that you have this menu open, all you need to do is type Flutter colon open dev tools and select this option. Then it will show you an option that you can either open up a particular dev tool or you can open up the set of dev tools in web browser. We're going to select open dev tools in web browser. When we do that, it will open up a new window of dev tools in a web browser as you have open here. Now moving on to the first dev tool, Flutter Inspector. Now this dev tool allows Excuse me. This step tool allows you to make changes to the UI of your application by allowing you to inspect and modify properties of widgets in the widget tree through various toggles, and you can see the effect of these changes live. Now, if you are familiar with Flutter development, you must be familiar with the widget tree, with how widgets have children and how they all form a tree of sort. Now, what you can do using this dev tool is you can go through this widget tree. You can select any particular widget in this tree, and you can change around and play around with the parameters and with the options for this that particular widget. And once you modify the properties to in a way that you believe provides you with a UI which is better suited for your application, you can change up your code to uh, follow those set of properties. I'll demonstrate this dev tool to you now. Here I have my Flutter application, and here I have my windows for dev tools. And I'll open up the Flutter inspector here. And as you can see now, I can see the entire widget tree of my application here. And sometimes when we want to use this dev tool, we may not be familiar with the exact location of the widget we want to play around with inside the widget tree. So for that, we can select the select widget mode option here and select the widget which we want to play around with the properties of. And as you can see, when I clicked on the icon, it found out where the icon was in the widget tree and selected it for me. So I'll move on to the parent row here. And when I do that, as you can see here in the Layout Explorer, I can see the entire row and its properties, along with its children, which are these two icon buttons here, and their properties as well. As you can see that currently the main axis alignment for this row is space around. I'll change this up to start, and as you can see, it shows the icon buttons as having moved to the start here. And in the application as well, the changes occur live. Here I can also change up the flex, and the icon buttons will start taking up the space accordingly. So you can play around with the properties using this dev tool, and once you figure out a set of properties which you feel give an appropriate UI for your application, you can go into the code and set the properties to utilize those set of properties. You can probably see other options here in the Flutter Inspector as well. I'll tell you what these options do. Now, slow animations. What slow animations does is sometimes you want your application has some animations which do not look as they should. So you can utilize this option to slow down that animation by 5 times so that you can better understand where exactly the animation is going wrong and you can fine tune it according to your needs. Then you have show guidelines. What this does is it creates guidelines around the widgets that your application has. So you can see the space exactly that is taken up by a widget and how they're being rendered essentially. And you can then change up the properties of your widgets so that you can make them look as you would like them to. Then there's one for show baselines. This is this shows up the baselines for all of the text in your application, and with that you can change around how exactly the layout of your text is. So when you have baselines for all the text in your application, you can better position or align your text according to your needs. Now highlight repaints option. Every time when your Flutter application repaints itself, it's a very performance intensive thing. So, of course, you want to keep these frame redraws or these repaints to a minimum. So, what this option does is it makes it so that there's a change in the border color of your application every time it redraws itself. For example, here, every time I press these plus or minus buttons, you can see there's a change in the color of the border of my application. So every time your application repaints itself, there's a change in the color of the border. So you can, with this, you can debug and see whether the repaints are happening only at the right time, and no unnecessary repaints are occurring, which can be performance intensive and have a negative impact on the performance of your application. Then you have highlight oversized images. What this does is images can occupy a lot of memory. So, what this does is it will invert the color of any oversized images in your application so that you can switch them with images that are perhaps more memory efficient. For now, I'll turn off these options and we'll go back to the slide deck. Move on to the next step tool. The next step tool is network view. So if you're familiar with app development or web development, you might be familiar with how the modern applications utilize internet for a variety of purposes, whether it be to make API calls to backend servers or other services, or you can utilize it to access network resources. So what Network View DevTool allows us to do is it allows us to monitor our application's network traffic. And this can help us identify performance issues and inspect client API interactions to ensure that the responses which we receive from the servers are as expected. Now, interacting with these external APIs or sending API calls is uh, something which requires a lot of resources of our application. So any unnecessary API calls can be a performance bottleneck for our application. And we want to ensure that no such unnecessary calls occur. And any calls that we do have to make, we receive the right response from the server. And the format of the response received is as expected. Network View DevTool allows us to ensure that easily. I'll give you a demo for this DevTool. We'll go back to our DevTools and here we'll move on to the network tab here. And we'll move on to the second screen of our application, which is an API screen. Here we have a get fact button, and every time I press this button, it sends a call to an API and gets us a fact. I'll press this button once more. And as you can see, another request appeared here. Uh, this section here shows us a list of all of the requests that occurred that are sent and are done by our application. And you can select any one of these requests and see a lot of details about that particular request, including how much time that particular request took, along with a split of how much of that was for the connection to be established and how much was that of that time was waiting for a response, and so on and so forth. You can see the method of the request, the status of the response received, and the URI as well as port that it was sent on. You can see the headers of your request. I will not scroll through all of the headers because it also contains the API key that I used, but you can go through all of the headers and you can of course see the response of the API of the response received through the API. Now, this dev tool is extremely useful because it allows us to forego having to write print statements for everything, including the status of the response received and then the response with all the parameters. It allows us to see all of that in one separate window, uh, which makes debugging API responses a lot easier. So you can see whether the status is 200 as expected, and that you are in fact receiving the correct response from the API, and then that the response is in the JSON format that you expect it to be, so that you can properly access it in your application, and it can be utilized as needed. I will clear out this window for now, and we'll move on to the next dev tool. Moving on to the next dev tool, Performance View. Now, Performance View can help us debug and fix stuttering or other performance issues by providing us frame-wise data for time taken by the UI as well as the raster phase, and data on the associated timeline events. I'll demonstrate this dev tool now. For a good application, what is most important to us? The performance is most important. No one likes to interact with a stuttery application. So to ensure that the application is as performant as expected, we have been provided with this performance dev tool. I'll go to this tab and clear the uh, response that we have right now. And right, when we scroll, we can see more of these bars pop up here on the screen. And each of uh, res- these bar corresponds to a particular frame being loaded in, and the blue ones show us that the time was as expected, with the red ones being uh, taking more time than expected. Now, as I scroll through this, you probably see a few blue ones with some red ones interspersed in, but you'll probably see that most of the red ones here also do not take a lot more time as compared to the expected 17 milliseconds. Some of this performance issue might be that because we are using the application in debug mode, which is not as indicative of release performance as profile mode might be. But some of these frames actually do go a lot over uh, the 16 milliseconds frame mark, uh, which you can see by the bars extending over the upper limit here. For example, we have this here with the raster phase taking 61 milliseconds and the UI phase taking 43 milliseconds. So when we go onto this particular bar and we explore the timeline events within it, right now I have enhanced tracing on, in which I am tracing the widget builds as well. So this will give us more information as to what exactly is causing our performance issues. Right, now that we've finally got the timeline loaded up here, we can view all of the timeline events happening here. Now I'll zoom into this a bit, and as you can see, we are one of the most expensive frames here, with the raster frame taking 53 milliseconds and the UI taking 36 milliseconds. And we are wondering why the frame is taking so long to load up. And for that, all we need to do is zoom in to this a little bit and explore the timeline events for this particular frame. And as we go here, you can see that we have a particularly uh, large stack here. And once we zoom into it a bit, we can see that under the build there is a list tile under which we have a widget named My Expensive Widget, uh, which has a stack under it having a lot of my normal widgets. So we uh, get to see that perhaps this widget here is contributing to the poor performance here, with this frame taking a lot more time than it should. So once we move back into our code and we go to search here and we search for my expensive widget, we find that on this screen we have a widget which is a stack of 100 uh, uh, containers. And as you can probably figure out, that is bad for performance because having such a big stack causes a lot of performance issues. So as you can see, we were able to figure out from this performance dev tool that we had a few frames that were taking a lot longer than expected, since they were going above, since the bars were going above the upper limit as well. And when we moved on, and when we looked into the timeline events corresponding to these particular frames, we were able to find which particular build event was taking a lot of time. And when we zoomed into it, we were able to figure out what exact widget was causing the performance issues here. Uh, this particular dev tool also gives us the performance overlay option. I'll enable it just to demonstrate its application. And once you enable it, it creates a performance overlay onto your application screen, which creates this frame-wise chart with there being two charts, one for the raster phase and the second one being for the UI build phase, onto and it overlays it onto your application itself. For now, I'll turn on the performance overlay and we'll move on to the next dev tool. The next dev tool is CPU Profiler. And sometimes when we're not able to figure out where the performance issues are coming from the performance dev tool, we use the CPU profiler dev tool. And profiling is a well-known performance engineering method, which is often used to analyze exactly how the CPU resources are being consumed by a particular code base. Since we can see the call stack for a recorded CPU sample, and we can order these functions by execution time, uh, it also allows us to see a top-down representation of the entire tree in the form of a table or as a color-coordinated frame chart. It allows us to really see which functions are really taking a lot of time to be executed and how exactly that is affecting the performance of our application. This is an image which is an example of a flame chart of an application representing a CPU sample. So I'll go into a little more detail for this dev tool again through the demo application. We'll bring up our handy dev tools as well as our Flutter application, and we'll go on to this next tab in our uh, application. And perhaps you notice that when I switched over to this tab, there was a bit of a stutter and a bit of a lag before it moved on. For this, we'll go on to the CPU profiler, and it provides us with a few options here. Now, I'll explain what these options are first before we move on to actually using the dev tool. Profile app startup, sometimes there's a lot of stuttering before when you start up the application, before any of the frames are actually drawn. So when you want to see the CPU samples for that particular phase before the first frame is drawn and uh, evaluate why performance issues may be occurring during startup, you can utilize this option. And there's an option for load all CPU samples. Now this option occurs here because uh, it loads all CPU samples from the profiler, and this includes data pertaining to isolates other than the main isolate. So isolate refers to the threads that the Flutter application utilizes to really do all of its work in. And sometimes it utilizes multiple isolates uh, apart from just utilizing the main isolate. And using this option, you can take a look at all of the CPU samples and not just the ones which are from the main isolate, which is as you can see selected here. For now, we'll start recording through our CPU profiler and switch between screens real quick. And after we have switched to the screen, we'll stop recording. It will process our CPU samples. Okay, and now that it's done with that, you can probably see a few options here. First off, bottom up, then a call tree, a method table, and a CPU flame chart. Now, what are these options? Now, the bottom up tab, as you can see here, shows a list of functions or methods which were called last in the call stack for a particular sample, as we recorded a sample right now. And these functions are, as you can see here, ordered by execution time, with the longest running function at the top. And apart from absolute numbers, these execution times are also shown as percentages here, so that uh, we can easily see which functions might be taking a bulk of the time. Uh, we also have a call tree, a method table, and a CPU flame chart. What is the call tree? Now, the call tree, it's a top-down representation of the entire call stack. So essentially, it's makes it sort of an opposite to the bottom-up table. And the method tree and the CPU flame chart. So through the method tree and the CPU flame chart, you can see uh, exactly how much time of the total percentage was taken by each of these methods or functions. And the CPU flame chart allows you to see exactly the same thing, but in the form of a color coordinated flame chart with the color coordinated flame chart really makes it a lot easier to understand what exactly is causing the performance issue. With these purple ones being methods, default methods through Flutter's methods, with the orange ones being the ones called by your written through your code or called by your application. So we'll move back to the bottom up chart here. And you can see at top we have a method called Fibonacci here, uh, which is taking 76% of the total time, which is a lot of time. So we can from that we can get an idea that perhaps this method is causing some of our uh, performance issues. And the flame chart as well, you can see that there's a lot, most of the orange portion of the table corresponds to this Fibonacci function only. So we get an idea that perhaps a function named Fibonacci is causing some of our performance issues. And all we need to do is go back to our code and search for Fibonacci. And here we have it, a function which prints the Fibonacci of 40 is being called in the end state for this particular uh, screen, and that is what is causing the performance issues. All we need to do is comment this out, and we fix the performance issues. Uh, this was a demonstration of how we can use the CPU profiler tool to know exactly what methods may be causing performance issues in our application and fix them, so that we can build a performant application. Moving on to the next dev tool, it is the memory tool. Now, the memory tool helps us ensure that no memory leaks occur due to unused objects in the heap. It allows us to analyze snapshots of the heap so that we can keep a check on unexpected memory spikes and memory leaks. Uh, So sometimes there are some unused objects in the heap. Dart does offer its own garbage collection, which removes objects from the heap which no longer have references in the stack. But sometimes there are some unused objects in the heap which still have references in the stack, and these are not automatically removed by the garbage collection feature in Dart or Flutter. And failure to remove these objects from memory is known as memory leaks, because these objects are still occupying the memory even though they're not really being utilized with the application. So we need to ensure that since memory is a uh, limited resource for any device, we need to ensure that our application does not utilize and does not misutilize any memory and does not use any memory that it does not require. So to ensure that no memory leaks occur, we have a dev tool for the same. So I'll demo you this dev tool. As you can see, we have a tab for the memory dev tool here. Sorry. And we can see the the current heap of our application with all of the objects and all of the classes that have currently been called here. And I'll give you an example through the memory screen of what it would look like if we had some leaky objects in our application by adding 1 million memory leak objects. And as you can see, when I press this button, we saw a a slight uptick in the graph here, along with a lot of these small indicators in the graph. And when we reload our refresh our profile memory here, you can see that we have a new object occupying 15 MB of our space, which we are not supposed to be having, which is not supposed to be taking up this much space. So now that we know that we have an object which is occupying unnecessary space of the name memory object, all we need to do is go back to our code. Uh, I'm sorry. Right. All we need to do is go back to our code and search up memory object, and we can find out that what object is taking up this unnecessary space, where it is being added from, and we can remove it to ensure that no memory leaks occur in our application. Now moving on to the next dev tool, it is logging. And the logging dev tool allows us to easily view print statements and logs in a separate window for easy debugging. So a lot of time during debugging, we utilize print statements or logs to make our debugging process easier and to figure out exactly where the code is going wrong. But sometimes when we are utilizing logging for debugging, you can find that the logs of the application or general debug statements generated by the application make it difficult to see the logs which were created by you or the print statements which were written by you. So what the logging allows us to do is it creates a separate window with all of the logs and the print statements created by you, and it allows you to go through them in a separate place so that you can easily view the logs created by your application and it debug accordingly. Apart from that, the DevTools also provide a full-fledged debugger in Suite, allowing you to create breakpoints and uh, you can utilize it to debug. And as you can see, I created a breakpoint here, and you can utilize it to debug the code accordingly. With that, I end my presentation on Dart Dev Tools. I hope that you are able to better utilize Dev Tools to create more performant and better applications. Thank you.